This is ChemQuest 33 and Skills Practice 33 about limiting reactants. For question 8, it gives you a paragraph that you have to use, and in the above discussion it was given that 20 moles of oxygen was not sufficient to combust 10 moles of propane. And you want to figure out how many moles of propane that can be combusted with the 20 moles of oxygen. And looking at the paragraph, you learn that 10 moles of propane, you need to use 50 moles of oxygen to burn it, meaning there's a 1:5 ratio of moles of propane to moles of oxygen. So to figure out how many moles of propane you need, you divide the 20 moles of oxygen by 5, and that gives you 4 moles of propane needed. For part B, it asks you how many moles of carbon dioxide will be produced. And so you're basing this answer based off your answer from part A. So you have the 1 mole of propane combusted produces 3 moles of carbon dioxide. So you have 4 moles of propane times 3, and then gives you 12 moles of carbon dioxide produced. Part C asks you to verify that if 12.5 moles of propane and 63.2 moles of oxygen were present, propane is the limiting reactant and oxygen is the excess reactant. To figure this out, you have to again look at the mole-to-mole ratio, and there's a 1:5 ratio of moles of propane to moles of oxygen. What you do now is you multiply the 12.5 moles of propane times 5, and that gives you 62.5 moles of oxygen needed. Then you look at and you compare. There's 63.2 moles of oxygen present, and since that's greater than the 62.5 moles of oxygen needed, the oxygen is in excess and the 12.5 moles of propane is the limiting reactant. Question 9 asks you to consider that chemical reaction and to assume that 0.75 moles of MgCl2 and 0.65 moles of Na3PO4 are placed in a reaction vessel. Part A asks you to verify that Na3PO4 is the excess reactant and MgCl2 is the limiting reactant. Since there's a 3:2 ratio of moles of MgCl2 to moles of Na3PO4, what you're going to do now is you're going to multiply the 0.75 moles of MgCl2 by 2/3 to give you 0.5 moles of Na3PO4. And the reason you're doing this is because you want the moles of MgCl2 to cancel out the moles of MgCl2, so you have the 3 on the bottom as opposed to the top. For part B, now you're going to find out how many moles of excess reactant are left over after the reaction stops. Since you know you initially have 0.65 moles, and you found the moles used of the Na3PO4, what you're going to do is just subtract them, and that gives you 0.15 moles of Na3PO4. Part C asks you how many moles of NaCl will be produced in this reaction, and again you're basing this off of part A and B. And since there's a 3:6 ratio of moles of MgCl2 to moles of NaCl, you're going to multiply the 0.75 moles of MgCl2 given to you at the very beginning by 6/3 or 2, and that gives you 1.5 moles of NaCl.